This time on Captain Castle's Laboratory, we're going to be working on a generic, but I think it's probably an old Avon piece. Lighthouse. There you go. Character came off, easily fixed with glue. And in transportation, the dome came off, which gives you access to the little light bulb, which again is easily fixed with glue. But just to show you the bottom, there is made in China, quality control, 12 volt, 5 watt. It's got no name, but it looks similar to some Avon pieces I've come across. So anyhow, what it's supposed to do when it's got power, there's no off-on switch, so you either plug it, sorry, there is an off-on switch. There's no off-on switch in the cord. When you plug it in and turn it on, that piece in there is supposed to rotate, that silver, to imitate the lighthouse going around in the circle. You can hear, it sounds horrible. You can see the fiber optics are working, and all the little lights right here. See them go out in a second, like that. So, the motor's bad, or the gears, drive, something has failed. So we're going to open it up and see if we can fix it. And then glue all the pieces back on. This is a resin top and a plastic bottom. So on the bottom, flip her over, you can see the plastic. And this is all resin. Some of these old generic pieces or Avon pieces, because a lot of the Avon again looks like this, they have pretty good color. That's a tight screw. There you go. So, I mean, when I say that, you can see the shading of the water into the wave crashing against the shore, and then there's the rocks are actually shaded to where you have grays and browns and whites. You know, they do the stuff that you do when you build your dioramas to make it look more realistic. And then the little seagulls are on springs. Oh, that screw was loose. So anyhow, we're going to, like I said, open this up, see what we can do to fix it. I think it probably just either needs a motor or the drive assembly is broken and needs to be repaired. On the bottom, you probably saw this protrusion with an X on the top. That's for the bottom light, not the motor. The motor is this piece here. This is for the light. There's a light on the top and a light on the bottom. The light on the top, of course, illuminates the lighthouse, the part that the boats would see. And the light on the bottom is for the fiber optics. And that motor may drive a pinwheel since they were just solid white. I don't know. I have not paid any attention to this piece as far as how it's supposed to function, other than it doesn't spin. Alright, it does have a pinwheel. Alright, what are we stuck on? I think we're caught on some glue. That sounds like a spring. We definitely got some short wires. And we got fiber optics. So what I'm hearing down here may just be the pinwheel, because it looks like there might be a motor at the top. Or, nope, there's a drive. Okay. It's really hard to take this one out, I'm not going to lie. This one has all sorts of crap connected to it that is really, really short. So, I have fiber optics that don't want to move. There's no slack. And then I have the power wires right off of this switch, which are literally about an inch long. That's as far as I can pull it out. They did not make this one easy to disassemble. So I'm going to unscrew the housing for the fiber optics, and that is these inner 4 screws. That'll relieve some of the stress. Now, a lot of these older, like I said, especially the Avon pieces, all the screws in the bottom are generally the same. So if you mix them up, it doesn't matter. The only one that's obviously not the same is the lock screw for the light bulb. because that has it's a flat top screw, whereas these are just button heads. Alright, so definitely need to remove the fiber optic housing. And the reason it doesn't turn is the shaft is actually snapped. I don't know if you can see on camera or not, but you can see the reflection. So I can turn it with my fingers. I can pull the shaft out. Unfortunately, the shaft is retained by something. But the shaft is supposed to be inside here. The shaft has sheared. See no retention in there. And then we'll flip her over. You can see the shaft right there where it's broke. Right there. Okay. If I can get the shaft out, I might be able to fix it. I'm going to plug her back in, and I want to see if this pinwheel turns. The noise we might have heard is just the shaft bouncing off the moving components. The motor might actually be good. Uh-oh. Oh no, that motor's bad. And the light bulb's bad too. And this belt is bad. Well, everything's bad. This belt is vulcanized. Let's see if the motor turns. Nope, motor's still shot. Alright, so we definitely need a motor. It's a TYC 40, 12 volt AC, 60 hertz, 12 revolutions per minute. So it's a fast turning motor, or it's supposed to be. Right now it's not a very fast anything. So that explains why the fiber optics were white. I don't know why the bulb's not working though. The bulb was working up until we took it out, so either something came undone or the bulb popped. It is incandescent. So it is very possible that the filament broke in the process of unscrewing it. We'll check that in a minute. I'm going to just snip these wires. Doesn't matter which is which, it's AC. So get that out of the circuit. And top light's on, bottom light's not. Strong springs. It's an MR8, which is a very standard bulb. It's 12 volts. So let's fire up a machine here. That's 12 volts. Let's turn it off for a second. AC or DC, incandescent bulbs don't care. LEDs do. But yeah, no light. No light and no load. There's no amperage, so the bulb popped. No big deal, it's just a bulb. My concern is more the motor. And I probably have a bulb in here too. Try to keep the MR, at least one MR8 on hand. It was a very common bulb for Yeah, pinwheels. Jeez, sorry. MR8 and MR11. This is an 11. So the difference between 11 and an 8 is the size of the bell or the reflector. But all I'm going to do is just double check that this still has good power. Okay. Alright. One more thing to figure out. Wires didn't break. I don't think this is a bad bulb. Brand new. Yeah. Just going to check this one more time just to make sure I didn't have a bad connection. You can use a meter to do this too, where you just put a meter on it and check for resistance. Yeah, nothing. So this bulb did pop. And here's the belt, which is severely cracked and vulcanized. Kind of, yeah. Yeah, that sounds horrible. So here's the problem. This shaft was glued in right there. I kind of see it. Freaking glare is ridiculous. There you go. See. So if there was a screw under here that held it to this piece of metal, I'm not going to be able to get to it. So that's going to pose a problem. But if you have something like this, grab a pair of wire cutters, find the tabs, and then use the sharp side of the wire cutter to slowly bend the tab up. That's because the angle of the wire cutter will actually get underneath the lip, and then you can fold the tabs. What we're going to end up doing is, if it's screwed onto that shaft, we can hold the bottom of the shaft where it's connected inside the motor, literally just be attached to this lid when we pop it off, and then we can try and unscrew it. Don't use a good pair because you will eventually damage the cutting part. Then the next part, we're going to pry it open. When you do this, be careful, because this is where you normally jam a screwdriver through your hand. Done it many a times. I'm going to need something a little heavier than that. So there's two flat spots on most of these motors that you can pry under. You just have to get something into there to pry. Like that. And then you can usually just pop the cover off. Again, don't use anything high quality. You know, the reason I use this screwdriver is the screwdriver is chipped, so it's not a high quality screwdriver anymore. So I'm not too concerned. I'll use a bigger blade though to finish prying it off, just to get a little bit more leverage. So, gears probably weren't a mess. They probably came apart when I popped it, but I'm going to put the gears back in. I don't see any broken gears. A lot of times you open these up and the gears are broke. Now I can try and I can grab this bottom part. try and see if it threads on. Definitely got to clean off my workbench again. Starting to get a little crowded. Oh, I need another pair of pliers. I know I have some around here. These will work. I'm assuming it's threaded. I could completely be wrong. I don't know. Oh, it's just glued on. So it's a D. It's got a D shaft. So the shaft isn't cylindrical. It kind of looks like the letter D. There you go. And all I did by twisting it was break the glue. There we go. Just needed more leverage. It's a blind shaft, which means that this piece that's glued in on the top, which is also shaped like the letter D, it's going to be really hard to get out. Might have to try some heat or a drill. I'm going to try and get rid of some of the excess glue so I can see the seam better. Definitely got a lot of glue in there. All right, let me see what I got. Let me see what options I have to try and reconnect to that shaft there. I really wish that shaft would come out, but it is retained, and I don't know what it's retained by. All I know is that if I pull down on the shaft, it disconnects. I think it disconnects. Nope, I think the shaft comes out the top. That's why I can't pull down. This has a seam. It looks like the shaft does come out the top. It doesn't fit through this hole. So this piece has to be separated. I see a seam that goes all the way around right here. I'm just gonna pry at it real quick. I want to get to that shaft because if worst case is I'm gonna end up replacing the entire shaft, but I need to be able to get to the shaft. Would normally use heat, but this is plastic and this is also old. A lot of times when it's old, the glue gets dry rotted and you can just easily pry carefully and it'll just come right off. Especially living out here where it's hot and dry. The glues don't survive. Let's not use any of that. There we go. so that's the railing. Be a good time to clean the dust off too. And here's the other seam. Excuse me. Apparently I aggravated a lot of the dust that's in here. So there is another seam, and that's what I'm working on right now. So this red or maroon piece is glued to this black disc, and this black disc is recessed into the cup. So now I'm going to try and see if I can get this this cup out. That way I can get the whole shaft out and see what we're going to do about the broken shaft to make this thing work like it used to. There we go. So there are wires that are running down it, so we're very limited on how far we can move this, but there we go. Serious. Okay. They glued a stop ring on the shaft as well. So once they assembled this, they glued a ring on to prevent you from pulling the shaft or the motor for pushing the shaft too high. That way if the motor's spinning, the shaft can't walk up and disconnect itself. Yeah, it's just glued on. No problem. The reason I need to get access to the shaft is the motor, however it attaches, isn't going to have this same fitting, which doesn't matter to the end of it's broke off in here. I might have to replace the entire drive shaft with something different. And I was hoping I could get this thing out so I can look at it and see what I can do to replace it or extend it, but it doesn't look like it's going to want to do that. Might have to heat up the reflector and get rid of the glue and see if I can slide it off. Yeah, it's just glued into the reflector. It does turn out to be a little bit more of a complicated mess than I was anticipating. I didn't expect a broken shaft, I just expected a bad motor. That was it. I just expected the motor to have failed, not to have the actual drive shaft shear off. It's not common. The only time it ever happens is if it gets caught, and I don't see anything that it can get caught on. I'm just using the tips of these as pliers to see if there's any slack and any brittleness in the glue that if I twist it, it'll... Nope. Alright. I don't want to break the reflector. You can make a new one. That wouldn't be too terribly difficult. But I'm going to look for a motor and turn on my heat so we can get this thing done. So I am going to heat this up and get it to separate and also look for a motor. I'm going to pause it for a moment while I do that. That way you're not listening to the heat gun. All I'm doing is the shaft is glued into this reflector on the bottom, and I just don't want you to listen to that. And I also got to see if I have a 12-volt motor lying around in AC. So I'll be back in just a moment. Okay, I'm back. While I was letting the air gun cool down, I did find my MR8 bulb that I have that's new. This is the motor I have. It's a 12-volt AC. It's a 6 RPM, so it's going to spin a little slower. The person that has this doesn't care. They just want it to turn. The inside's threaded. It's going to be hard to see, but the hole has threads. So I did get this apart, but not the way I wanted. I did heat up the glue, but all it did was this just melted. And that wasn't even going hot or very long. So not a problem. Here's the shaft. So it's just a big piece of plastic, or it's probably nylon to be truthful. The glue here didn't even start to change colors when this turned into liquid, meaning it didn't get glossy, or some glues get darker, some glues get lighter. So whatever they use for the glue here, this looks like it doesn't look like resin, it looks more like an epoxy, is way stronger than the plastic rod. Not a problem. There's always ways to fix things. Here's the motor, which of course being a round shaft as well. I am going to go to the hardware store and see if I can get a piece of all thread. All thread is just a piece of metal that's long, that's completely threaded, that I can thread into this that go the whole length. And I would just drill this out, one size under, thread the hole, put a dab of glue in there, and then we would have our new shaft. And then I would just put a new pulley on here to drive the pinwheel. Also, when I was doing this and getting it hot, I realized that not only was it glued, but this top was screwed. So if you have this piece, don't do what I just did. You'll end up breaking it. These little standoffs are actually, see if I move the light, will you see it better? Kind of. Yeah, right there. They're screws. And if you look underneath, the top is screwed and glued on. So I'm just going to use hot glue to reassemble it. So full disclosure, if you have this piece, don't do that, because I didn't notice the screws because they're recessed deep inside the plastic. There's 4. Anyhow, so that's what I'm going to end up doing, is I'm going to see if I can get some all thread in this size. If they don't have all thread in this machine screw size, I'm going to make or use an adapter. They do make adapters for synchronous motors. They're usually pricey for what they are. They're small pieces of plastic, and they usually run you between $30 and $60 that allow you to adapt a threaded motor to any type of shaft up to about the diameter of a pencil. But you need room in here for it to move, which there is plenty of room in here for it to move as long as it doesn't grab any of the fiber optics. So you'll have to test fit it. So there's plenty of room, it's just are the fiber optics going to get in the way? But anyhow, so I'm going to see what I can find to make this motor work. Most of the 12-volt motors I've found that are available to purchase, they aren't the same size, or the D shafts are freaking huge, which means you got to grind them down. But that doesn't matter, because this piece is almost completely ruined anyway. But I'm going to keep it for now, just in case I can drill that out and make something work. And I would normally just drill this to a round hole and slide this in, except that this hole, even as a D, is bigger than this shaft. You can tell by sitting it in there. I have side-to-side play, so it's kind of still something I'm going to keep and maybe use in something else if necessary. So at the moment, I have a replacement motor, I have a replacement bulb. I'll check the wiring. It might have, when I pulled it out, it may have pulled the solder joint in here, so I'll see why this isn't getting power. I know this bulb is bad. I'm putting 13 volts to it and it's not lighting up. And the other bulb, I put 13 volts to it and you saw it light up. So, and it does look like when I tip it in the light, it looks like the filament is on the bottom. And you can kind of hear it when you rattle it. So, like I said, not a big deal. I try to keep 1 or 2 pinwheel bulbs on hand, because I own some pieces of pinwheels, and I fix several a year that are pinwheels, and some are the big and some are the small. So, and not a big deal. But anyhow, So I'm going to pause it, and I'm going to make a trek over to the hardware store and see if I can get some all thread and see what we can do. And we'll continue. So I shall return. Alright, I'm back from the hardware store. The light works. Apparently, the new style MR8 bulb is slightly different. I'm going to show you. I'm going to have to get a replacement bulb because this is an MR8 and this original one's an MR8. See the height difference? Yeah. So, when it's getting warm, it's been on for a minute. I'm going to have to get the short one. So apparently I only have the long. So I'm going to have to order from Amazon, get a bulb. This bulb is bad. The reason this wasn't working is the that also the other MR8 bulb has a shorter set of those. So the 2 pins are shorter. So you have to like push it really down and then it turned right on. I'm like, oh, so because when I put a meter in here, there was power. So apparently this older style MR8 has, or this different company MR8 has longer leads and a shorter lens. So I'm going to have to do that. Reason to do the shorter lens is this. When I set this in here with that bulb, the tops of the springs hit the plastic. No good. And you could technically try and slide this up, but it is glued on. Sorry, I was off camera, didn't realize. But I'll just get the right bulb. Not a big deal. As far as the motor goes, I did go to the hardware store. I got small thread. And you're probably going, well, that's too short. It's not even as long as the original, which is true. But I went through my random nuts and bolts and found what they call a coupling nut. And I marked how far down it goes, so they are halfway on each. And voila. Now, this is longer than the original, which means I can cut it to fit. So this is, in case you have this piece or you have this motor with the internal threads, this is 440 thread. That's your thread pitch. Apparently they don't really make 440 and 12-inch rods because it bends too easy, so it's always in 6-inch rods. The next size up, which is 632, they do, but that's not a 632 motor. So I screwed this all the way in, and I put a little mark on with the kind of see right there, the green. That's how far in this rod is threaded, just to give you an idea. And then that second mark, which is right there, was for me to line up this pulley to be the same height as this groove. And I was off by a little bit because this motor is a little bit taller. That piece is taller, so I had to push it down to compensate. Because this one, the bushing, is all the way recessed inside the casing, and this one's not. So basically, I just put them next to each other and then marked it with a pen marker. But, so when this goes on, it's going to stick up too high, which is fine. Like I said, this can be cut. This is very easy to cut. That's what these holes are for on your wire cutters. They even tell you 440 is right there. The 440. And that's for cutting this stuff. So my plan is to put this in, rewire it, reassemble it so this is sticking out of the top, cutting it to the right height, and then if I can get this, I'm going to drill a hole right there. This is a divot. You can kind of see it's divoted, so it'll self-center the drill bit. Because this epoxy I was working on, you can see the gouges. I cannot get this stuff off. This is not like a resin. This is like a real epoxy. I was going to drill a small hole that's smaller than this. And then take the piece of this that I cut off and use it as the thread. I'm going to use it as a tap, basically, to tap the hole and cut it. Because even looking at my tap at die set, I don't have 440. This thing is so freaking small, it's not funny. I do have 632 though, which is too big. So this is going to get a full makeover, rebuild, internals, whatever, which is fine. As long as it works, that's the end goal. And then that way it'll spin. So far, if you want to know, this motor cost originally like $7.80, and these 2 sections of rod was a little over $4 with tax. So right now, about $12 into it. This, nobody had it. You can probably order it locally or online. This I had in my random nuts and bolts. This came out of a computer for a circuit board standoff. One I disassembled a long time ago. I have several of them. But if you go by the prices of the 632, this is probably about $1. So literally this whole thing so far to retrofit it from a broken plastic rod to a metal rod with a brand new motor, including the light bulb, you're probably talking 20 bucks, which you can't replace this for 20 bucks unless you can find one, maybe at a garage sale, if this is your thing. This is my parents', and because my dad was a sailor, Lighthouse. That's why I'm going to rebuild it and make it work for him. This pulley, it has a gear on the bottom. I don't even know where this came from, but when I was going through my pulleys, this pulley had the same size hole as this shaft. So I literally just pressed it on so it doesn't turn. That way it will drive the belt. And I don't care about the gear. I have the gear pointing down so it doesn't catch any of the fiber optics. It probably came out of something I tore apart, like a VCR, Walkman, something like that. But you can find pulley kits, and you just have to get the diameter. This is a 3.5, give or take a point, diameter shaft, and they do sell pulleys with holes up to 5 millimeters. So you can get a pulley kit. You can't buy it singular, but if you have stuff lying around, you might have one. I mean, just to give you an example, look at the size of that hole. That's like I think it was a 6 because it's a specialty piece. But anyhow, that's why it's the Random Junk Channel. I have random junk lying around that will fit. Now, you're probably saying, oh, well, that pulley's bigger than that pulley. You'd be correct. Again, my job is to make this thing spin. It's not going to spin at the same speed for 2 reasons. 1, the pulley is shifted size. 2, this motor is half the speed. As long as I can get it to spin and imitate a lighthouse, that's fine. The ratio shouldn't be too far off. I mean, we still do have the larger pulley here. As far as the belt goes, once I get this in, I'll figure out the belt diameter. Of course, I'll have to slide the belt on this first before I push this through, and that's pretty obvious because once this is all the way in, the belt's not going to slide down because I can cut on fiber optics. This belt might be, well, besides this belt's trash, but this size belt might be too small now, and I'll have to go one size up. But this belt looks to be about a 40 millimeter. It might need a 45 or a 50. Those are the standard sizes for belts. I usually get mine from Skull Crane. I usually leave a link below because I find their belts are like far superior to everything else I've come across. They're very flexible. They're very sticky. Not like, ew, it's nasty, it's sticky, but sticky as in it grabs. So you're less likely to have a pulley slip. And they have some stretch, which allows for if the motion gets caught or jerks, the belt will stretch to absorb the shock. And they're a decent thickness. They're slightly thicker than factory belts, and so far, I haven't had any issues with them. Factory belts, this is what they call a square belt. So the belt has 4 sides, and all the Skull Crane ones are round, like a O-ring. I prefer the round belts. I know why they have square drive belts. It's totally fine. It's like cars have V belts. It's just the shape of the thing. The belts are tapered, so there's still 4 sides, but it's shaped like a pyramid if you looked at it, a cross section or a trapezoid. But they're all different. I still prefer the rounds. If you look at this pulley, you see how it's kind of a V shape. So the square only touches on the shoulders. The round will conform towards the center. That's one of the reasons I like the rounds. Now, if this was a square pulley, meaning that there was no V shape to it, you can see get dark. You can see the V shape. If there was no V shape and it was more of a square shape, then I would go back to a square belt. But even like this is a square. You can see how it's not the same as the V. The round will fit in here just fine. But this, it's hard to see, but it is tapered. So it's a V. You can see the V. and you can see where the V was catching with the seams, especially that right there. The seams were catching not the part from my tool, but the part where there's a lip that's black because of the square shoulder. So, but anyhow, a stupid little thing on belts, and why I prefer the rounded belts over the square belts. I am going to probably hit that with some rubbing alcohol and a cotton swab to get that black out of there. Just have a nice clean mating surface. And it spins pretty good. So at the moment, I'm going to pause for a second. I'm going to go ahead and probably get this soldered in and mounted, and then I'm going to order this light, because once this is in, I just got to shove it through and screw it back together, but I need this light. So it's going to take a day or two from Amazon if they're in stock. Now, because of how far this goes in, down to that line, I did not put anything on here, so there's no super glue, Loctite, nothing, because it ain't coming unscrewed. Now this, you can see how it wobbles. Once I have everything prepped, I am going to put a drop of super glue on the threads on both all threaded pieces, so that way it's rigid and there's less likely for this to unscrew from the motion. So I'm gonna, and the reason I'm not using Loctite is if this ever comes back apart, we have to know to undo the top and unscrew this reflector. But if I pull this back out, you saw my room was very short. I can grab the top piece and crack it free, because super glue doesn't like to bond to steel. You can also use nail polish, and maybe I'll use nail polish if I can find it. Nail polish will bond to metal, hold it in place, and then you can crack it free. I use clear nail polish because it works better than the colored stuff. So any of the colored nail polish will do the same, except their bond is a little weaker when you're using it for threads because of the pigmentation stuff they add to it. But anyway, clear nail polish was a great thing for metal on metal connections. It's not as strong as Loctite, but it still works beautifully. I've used it on small parts in projects like this. I've also firearms to hold screws in and allows you to take them back out. Automotive, I've used it on cars, so you'd be surprised what clear nail polish can do for you besides making your fingernails shiny. So, but anyhow, so I'm gonna go ahead and pause this. I'm gonna, like I said, get this stuff prepped, and I'll see if I can find my clear nail polish and show you what I mean. And I think I know where it's at. And I'm gonna order this light, so that way I can just put all that together, shove it in, get the top, cut it, and then thread this in and reassemble. Glue all the little pieces back on, and it should be good, and I can send it back and go back in their little sailor display. So, but yeah, that's where we're at. And all together, like I said, probably about $20 in parts. A little more time because I didn't expect this to be a broken piece, but it is what it is. It's old, it's plastic. So I wish there was a date on it to tell you how old it is, but it's been around for a while. I know it's gone through a couple of moves. When I say moves, I don't mean like down the street, I mean across the country. So, alrighty, shall return once I get that light. We're back on the Lighthouse. It's taken a month to get this light bulb. It's an MR8 12 volt 5 watt. Nobody locally, meaning within the United States, had one that I could find. They all had the heavy wattage ones that were excessive, causing the motor not to turn. So ordered this from overseas, and 30 days later showed up at the door. So they come in 2 packs, so I have a spare. Anyhow, I have cut the shaft to the height that I approximated it should be. It might be a thread or two too high. Well, we're going to find out when we reassemble it. And then, while waiting, I did drill the hole like I mentioned. You can see it's right there. And I threaded it. And how I threaded it is when I cut this shaft, you now have the remaining piece, which has a jagged edge, because I used, if you don't know, this to cut it. These holes here tell you the thread pitch, and that's what cuts stuff like this. It's designed for electrical stuff where you have to trim a screw, and it works for all thread too, the small stuff. So I just chucked it up, and then that way it cuts the holes into it, or excuse me, it cuts the threads into the hole, and there you go. You have a cheap plastic tab. That way, once it's assembled, I can just screw this on, and this should rotate. I am going to put a drop of glue on the threads to help hold this. This is glued, this knuckle, or coupler nut, I think is what it was called. So now, just need to solder all the wires together, re-adhere them, screw this back into the piece right here, and then test fit the top. While my soldering iron is heating up, there's the new bulb. You can see it clears. There's the new belt, nice and springy, not vulcanized. And we just got to solder all these wires together. So that's going to be our next thing. We're also going to need to heat shrink them because, well, it's power and we don't want them to arc and cause problems. So I'm going to pull out some heat shrink, and probably don't need a long one, so we'll go ahead and cut this in half. So this is AC. So being AC, it doesn't matter which of the wires you connect. There is no polarity issues. So it's not like you have a hot and a negative. You just have two hots all the time. So I'm going to give it a little bit of a twist. Try and get these wires together as best as I can. And then I'm going to slide the heat shrink over to ensure it covers both. Which looks like it does. There we go. I'm going to slide it down far away, out of the way of the heat from the soldering iron. And then now we're going to do it again for this side. You could slide the heat shrink down the single wire, but the reason I'm doing it on the double is I wanted to make sure that it will actually fit over the double wire, because if it didn't, then I would have to go to the next size heat shrink. Solder should be nice and toasty. Oh yeah, she's good. You don't get a lot of room in here to move, so you got to do what you can with what you got. You could technically take that out and give yourself some more hand room if you have this piece or something similar. The fun part is just trying to get this to wrap. There we go. Good penetration all the way through. So that one should be good. And now we're going to do it to this one. And of course, before we make it fully permanent, we are going to plug it in and make sure it works like it's supposed to. It won't work super efficiently because there's the housing in there holds the top of this. So I'll probably try and center it with my finger so it doesn't pull the pinwheel off to the side, or the color wheel. No, that one's not as good as it should have been. That's better. And take the one that's been cooled off a little bit. I'm going to slide the heat shrink up. And the reason I'm sliding it is in case the two touch each other while I plug it in, it doesn't arc. So now one of them is insulated. There we go. All right, lights are on, the motor is turning. So that's a good sign. Now let's put the pinwheel on so you can actually see the motor turning. Now on the camera, it's hard to see things that are small or have no reference of motion like the pinwheel will. So I'm just holding it so it doesn't pull off to the side. You see the movement? It pulls it off and it just barely clears the spring right here on this side actually. So make sure that's seated. Yep, and it reverses direction like most AC motors do, unless they say CCW or CW only. We're going to turn off the soldering iron. And move that back out of the way. And it looks like we may not have had this heat shrink far enough away for the amount of heat because the tip of it is shrunk, which means it's not going to slide over my solder. Maybe. I'm trying. Sometimes you can stretch them. Worst cases, they have electrical tape. Hey, I got it to stretch. That's good. There we go. Now we just need to heat it up. So we're going to use a lighter. Just need to get the fluid on the right side. There we go. So I have another set of small zip ties in here. There's one. That way I can kind of hold these wires down. So this standoff is the pinwheel, and zip tying to that would be stupid because it just slide up and smack the bottom of the belt. So I'm going to zip tie the wire to the one with the motor, which is right here. And what that'll do is it'll hold the wire down so it doesn't lift and get caught into the rotating mechanisms. And that'll keep it down. It's important to do wire management on a lot of things. As a matter of fact, I've been doing that a lot in the last few weeks. I've been working on rewiring a truck, and you got to be careful with the wires, where they're located, make sure they don't interfere with stuff. So you got to have your wire management in place. That way you don't have a problem. So now comes the next thing, which is now I got to get this inside. This is where having a removable shaft would be nice, but it's all glued in. I should have soldered it when it was technically inside, that would have been really hard to do. So let's see about what we can do to fix this. Let me move my phone so it stops vibrating so much from the cameras. Alright. Yeah, because this is all glued together as one piece so it doesn't unthread while it's being used, since it does reverse directions. Alright, let's see. There's actually more wire inside that should allow me some slack. Hopefully a little bit more slack to position this into place. Gives me another inch. Sometimes that's all you need. So I can get it in. Now I just need to feed it around the fiber optics. There we go. No idea what that is. That's stuck in the fiber optics. It's just a piece of trash. So I cut off a small zip tie that they had in here. I'm going to replace it now that I got the the base in alignment. So if you have this piece, make sure you don't catch it on the fiber optics, that you're zip tying just the wires if you have to replace this zip tie. Again, this is their wire management, like so. And like so. Now comes the fun part. So can't pull the fiber optic piece out far enough to line up the screws, it looks like. That's the problem with fiber optics when they do it like this. I like fiber optics, but sometimes when they do the manufacturing, it makes it really hard. So I'm going to see if I can hold it and at least get one of them to line up into their screw holes. Looks like that one will. I think I grabbed the wrong screw. That should be the right screw. Okay, there's one. Don't have it screwed in all the way, and that's so I can get another one to line up, since there's what, 3? 4. So let me see if I can get one of the ones on this side to line up. To do that, I'm going to have to rotate it so I can see it. There we go. That one's in. Now we'll do the next one. The rest, since I got 2 of the 4, the other 2 should just be completely lined up. retighten the first one. The first one isn't tightened, it's just in enough to hold it. There we go. There's the first one. Now, because of the age of this, you just got to go slowly. That's why I'm not using an electric screwdriver. Is because I'm afraid it will, even though it's not a super strong screwdriver, you don't have the tactile feeling of the plastic. So you can't tell if you're about ready to split it or not. There we go. I know some of it's off the edge of the bench a little bit, but sorry, the bench is so wide I can't see it all. Now I'm just making sure that everything is clear of everything. I need another zip tie. So the wires are lifting and they're touching the rotating disc. So I'm going to add another zip tie to the motor. Apparently when I zip tied just the motor wires, that wasn't enough. And luckily, I have these thin needle nose pliers. They'll help me feed everything. So, there we go. And I'm going to need you back. So, there we go. Nope. Let's try that again. Let's actually get the side that has the zip clicker, the teeth, on the right side. There we go. Now everything is clear, so now we just need to get the base on and get this to line up to the shaft hole in here. This was so much easier to line up when it didn't have wires attached to it and I could freely move it. There we go. So, custom is not always fun. It doesn't always go as you like. But you do get, on this, you'll get longer life out of it because it's not, that's the wrong screw, but it'll hold it for me. Its life will be extended because you don't have to worry about the plastic bar breaking again. It'll be really hard to break the metal. I mean, anything's possible. But sometimes you just gotta do what you gotta do to make it work, since if you really like a piece and you can't replace it, sometimes full modifications are required, and this one will be a full mod. Sometimes it's enjoyable and sometimes it's not. Just did it yesterday, work on the truck, and yeah. Yesterday wasn't too bad. Everything kind of went okay. Didn't have any major issues, but a few days prior, everything seemed to fall apart every time you touch it. So at that point, you either step away, which is what I did, and just let it sit for another day, or you fight through it. I didn't want to break anything, since I do drive the truck on the daily. I don't need it broken. So there we go. All right. So now we just have the shaft sticking out, and this should just thread on. Of course, we have to get it to line up because it's eccentric, so it wants to tip. There we go. You could turn the motor on and have it thread in. I want to do this to make sure it's not catching on any of the threads and potentially break the plastic, as this is an old piece. What's nice about the threads is you can adjust how high off the plastic deck you want it. So it's almost touching. Now it's touching the deck, and the shaft is just below the top. So now I'm going to back it off half a thread, and then we're going to turn it on and see if it rubs. So it does rub just a little. So I'm going to go a little more. You see it turns directions. It's not rubbing. So another advantage to doing a threaded shaft over the solid plastic one is, now granted if you had the original it would be the right height and you wouldn't have to worry about it. But with the threaded shaft, if you can't get the base to thread flush or you have to do something else, you have a little bit of an adjustment. You saw there were 6-inch shafts, and I used one 6-inch shaft for the coupling nut, and this is what's left over, which is 3.5 inches approximately of threaded rod. So that means this 6-inch shaft is about 9.5 inches, and this rod is about 9.5 inches. So that means that this part that broke off was probably, because it was glued in, probably close to the top where that dimple was, or if it may have been the dimple and then they filled it with glue and then sprayed it with the silver plastic chrome. So now it's just reassembly as far as gluing the top on, gluing on the pieces that came off, gluing on the character, and then we'll do a low light test. So I'm going to go ahead and glue it because I'm sure most of you know how to use glues as far as the reassembly goes. So I'm going to put this back on. I'm going to glue it with some super glue. Probably go between the two. They're both the same. One just has a brush. And then we'll do a low light. See what it looks like now that it works again. So I'll be back in a few moments. Okay, it's glued together. The glue is set. So here's what it looks like. This is the lowest light I can make. I know there's a lot of white light over here, but that's because there's a window and it's daytime. And I live in the state that's closest to the sun. And as if you look through the top, you'll see it's rotating and blocking the light. Look at that. So there you go. There's the pinwheel doing its job. You can see I don't know if you can, but the color, there you go, the colors are changing. So it was kind of a pain. Not a beginner level project I recommend. You'd have to have a little bit of mechanical and some critical thinking skills to trying to figure this out in your head. That's why I do this, is to help shorten the time that it takes for you guys to repair your own pieces. Whether it's a plastic one from I think the 90s or 80s from, I think, Avon. Like I said, it looks just like the Avon one I have over there. That's a Christmas one. Or a Lee Max or Department 56. The point is if you really want it working, you may not get it back to original, but you may get it close. So externally, it looks the same. Internally, we know it's different. We have different drive mechanism for the top piece. We modified the top piece. Doesn't matter I drilled a hole in it. You can't see it. It's got a cap on top. Now, if you pop the cap off to change the light bulb, sure, you'll see it. But if you didn't ever pop the cap off to change the bulb in the first place, you would have never known it was an original. So it's just one of those things where, hey. So I think this whole thing is like $20 with the lights that I had to order from China. And the all thread, the rod, coupling nut, and then the belt. The belt comes from Skull Crane as part of their kits. The rods came from Ace Hardware, and the coupling nut came from my bucket of miscellaneous nuts. So you can probably find them online. It's an electronic size coupling nut. Usually like a standoff for a circuit board, or the grounding standoff for a circuit board, since it's metal, a lot of nylon or plastic. So, but there you go. There is the Lighthouse done, completed, with a functioning Lighthouse rotating assembly. And I think we replaced the motor too. When it sits for 4 or 5 weeks in a box or on the bench in the corner, sometimes I forget all the stuff we put in it. I know we had to replace the belt, replace the up shaft. I think I replaced the motor. I'm gonna have to go back and check. But if I did replace the motor, which I'm sure I did, it was $27. But again, it's not that I don't remember because I didn't do it. I don't remember because it's been 5 weeks, and a lot of things happen in 5 weeks. So there we go. Lighthouse is done, and I can give it back probably this weekend. There you go. Lights up, rotates. That's all it does. So until the next one, thanks for watching.